Right. So this one here is a question whereby you are going to prove by letting matrix A be this and matrix B this, show that the inverse of the product matrix equals the product of matrix of the inverse matrix B by inverse of matrix A. So this one here, you can see that here we started with A and here we are starting with B. So this is very, very important. So first of all, we have to find the product matrix. We have to find AB first of all. So AB will be 1 minus 2, 3 minus 1, and then 2, 3, 0 minus 3. So this is a 2 by 2 matrix. This is a 2 by 2 matrix. If the number of columns in the first matrix is the same as number of rows in the second matrix, then the matrix multiplication is possible. In other words, the middle terms are, or middle numbers are the same. If the middle numbers are the same, matrix multiplication is possible. Now, how do you multiply matrix? You multiply row by column. So this is 1 times 2 plus 9, 1 times 0, 0, 3 times this, minus 9, negative 2 times this, minus 4, negative 1 times this, minus 3, and then negative 2 times this, 0, negative times this is 3, negative 1 times this. So you multiply row by column. 1 times 2, 2, 3 times 3 plus 9, 1 times 0, 0, 3 times minus 3 minus 9, and then you are done with the first row. You go to the second row, multiply row 2 by each of these columns. You get the numbers that are in second row, first column, second column, respectively. So this will be 11 minus 7 minus 9, 3. So that is AB. This is AB. Now, how do you find the inverse of AB? The inverse of AB, you find determinant of AB, which is the product of these numbers, which is 3 times 11, minus the product of this, minus 7 times minus 9. You multiply numbers that are in the leading diagonal, subtract the product of numbers in the other diagonal. So that will be 33 minus, negative times negative is positive, so that is 63. And this is minus 30. So that is the determinant. How do you find the inverse? A, B, inverse. It is minus 1 over 30. So you multiply by the reciprocal of the determinant. The reciprocal of minus 30 is 1 over negative 30. You invert it, it's minus 1 over 30. So, and then you interchange numbers with AB. You interchange these numbers. You swap 11 with 3, so that will be 3 and it's 11. And then you change signs here, that is 7, that is 9. So that is the inverse of matrix AB. Don't remove the brackets, leave it as it is. Don't combine this with this. Otherwise you'll be complicating things. Leave it as it is. Now let's go to A inverse, the inverse of A. We have to find the inverse of A, we have to find the inverse of B, so that we can multiply this. Once we have multiplied this, we check the answer. If the answer is the same as this one, then we conclude that we have shown that AB, the inverse of AB is the same as the inverse of B times the inverse of A. Right, so we are going to find determinant of A. Determinant of A is 1 times minus 1 minus 3 times minus 2. So this is minus 1 plus 6, which is 5. Therefore, the inverse of A is 1 over 5, and then you swap these numbers here. It's minus 1, 1. You change the signs here. It's a 2 minus 3. These other diagonal, you don't swap them. You change the signs. These ones, you swap them. So this is the inverse of A. Let's find the inverse of B. Determinant of B, it's 2 times minus 3 minus 3 times 0, which is minus 6 minus 0, which is minus 6. Determinant, you always multiply numbers in the leading diagonal. Don't mix them up. You don't multiply these numbers, then subtract this. It should always be product of numbers in the leading diagonal minus product of numbers in the other diagonal. Okay? So that will be minus 6. And then let's continue here. This is the determinant. Therefore, the inverse of B, it was 1 over minus 1 over 6 times, where is B? B is here. So this is minus 3, 2. This one, minus 3. 0 does not have direction, so you cannot change the sign. It doesn't have a sign. So that is the inverse of B. This one is the inverse of A. So once you have that, you have to find the product. Where is the product? It's B inverse times A inverse. And the B inverse is minus 1 over 6 times minus 3 minus 3, 0, 2. And then you multiply by A inverse, which is 1 over 5 times minus 1, 2, minus 3, 1. So when you have this kind of multiplication, you can rearrange this so that the numbers that are outside, you put them closer. This will be minus 1 over 6 times 1 over 5. And then this one here, it is minus 3, 0, 2. And this one here is minus 1, 2, minus 3, 1. And this one, negative 1 times 1 is negative 1 over 30. And then we do the matrix multiplication. Row by column. Minus 3 times 3 is positive 3 plus 0. Minus 3 times minus 3 is plus 9 plus 0 times 1, 0. Negative 3 times negative 1 is 3 plus 2 times 2 is 4. Negative 3 times negative 3 is minus 9 plus 2 times 1, which is this is 9 plus 2. 9 plus 2. Okay, it's fine. Negative 3 times negative 3 is 9. 2 times 1 plus 2. And this will be minus 1 over 30. And this is 3. This is 7. This is 9. This is 11. Now let's compare this answer to this answer. Are they the same? Yes, this is 3, 7, 9, 11. Negative 1 over 30. Therefore, AB inverse, the inverse of product, is the same as the product of inverse of B times the inverse of A. Hence, shown. Right, we have shown that this equals this. So when you have a problem like this, step number 1 is to find the product of AB. Once you find the product of AB, you find the determinant of AB. After finding the determinant of AB, find the inverse of AB, which is this. Leave it as it is. Don't multiply each number by negative 1 over 30. Leave it as it is. Then you go to the next one where you find the inverse of A. To find the inverse of A, you repeat the same process that you did under this one. You find the determinant. Once you find the determinant, you find the inverse. And then you find the inverse of B, same process, determinant, then inverse. Then multiply those inverses together. Then you get to this answer. Compare. If they are the same, it means you have shown that inverse of AB equals the inverse of B times the inverse of A. So in the next video, we are going to deal with the transpose. Let me stop this one.